guys, welcome to Engage New York, Module 4, Lesson 27. This is the concept development. So today's big idea is we're going through several word problems and we're going to use different methods. Any way that is mathematically sound is perfectly perfect to solve these problems. We're going to solve problems involving fraction division. That is our big idea. So let's get started. Joey bought 3 mini cakes for a birthday party. She cuts each cake into quarters and plans to serve each guest 1/4 of a cake. How many guests can she serve with her cakes? Now, you've been doing problems like this for several lessons now, and you should be getting better and better and better at it. So we're going to attempt this problem with the tape diagram method and with the number line method. So, first of all, can you draw something? What can you draw? And then after you draw something, do you have any conclusions? What conclusions can you make from your drawing that will help you solve the problem? Well, we have Joey bought 3 mini cakes for a birthday party and she cuts each cake into quarters. All right, so let's start with a tape diagram. So here are our 3 mini cakes. Then we're going to cut those into how many? Into quarters. Okay, here's 1, 2, 3, gives us 4. All right. And plans to serve each guest 1/4 of the cake. How many guests can she serve with her cakes? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And she's going to give each person 1 piece of the quarter, right? Well, when you put all of those together, what do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. She's going to serve out of those 3 mini cakes. What fraction is she going to serve them? You're right. She's going to serve them 1/12. Well, can we solve that with using an equation? So we have 3 mini cakes and we're going to what? Divide them into quarters, right? So what do we know? 3 times 4, right, is what? 12. She can serve 12 people because she's going to give each person 1/12 of it, right? So she can serve 12 guests 1/4 of a cake. So we have this whole here, and these are 3 mini cakes cut into quarters. So 12 fourths are in 3 wholes, correct? All right, now let's try it with a number line. All right, so here is our number line. 0, 1, 2, 3. We have 3. Now, here are 3 wholes, right? 3 mini cakes. And now we're going to divide those into quarters. Well, here's 1/4, 2 quarters. Here's 3 quarters, 4 quarters, 5 quarters, 6 quarters, 7 quarters, 8 quarters, 9 quarters, 10 quarters, 11 quarters, 12 quarters, right? So there are 12 quarters in 3 wholes. So if she cut each one, there are 12 quarters in 1 whole. So the answer is the same. Joey can serve 12 guests. That is the answer. My pen is not as bright as it was. All right, That is problem 1. Now let's move on to problem 2. So do you see how we use 2 different methods? But I definitely drew out, I solved it using a tape diagram, I solved it using a number line. Whichever mathematically sound way you can solve this problem is the way you should. However your brain works best and however it sees it and makes sense of the problem, that's the way you want to go. All right, our next problem. Lori has 1/4 pound of lasagna left in the refrigerator. So what does that look like? So here is a pan of lasagna, and she only has 1/4 left. That means 3 of the quarters is gone, right? She wants to cut the lasagna into equal parts so she can have dinner for 3 nights. How much will she get each night? So we need to cut this into thirds, right? All right, so what does this look like? Well, 1/4 of a pan, and we're going to divide it into 3 days, correct? What does that look like? Well, 1/4, I have to inverse, right? I have to convert this and convert it into the inverse operation and multiply by the reciprocal, and I end up with 1/12, correct? So how much will she get each night? Lori, here's the real answer, will get 1/12 of the lasagna each night for 3 days. So Lori will get 1/12 of the lasagna each night for 3 days. Now that's the actual answer. Yes, this is the numerical answer, but you have to actually answer the question. And the answering the question is Lori will get 1/12 of lasagna each night for 3 days. Okay, moving on to problem 3. All right, problem 3. The perimeter of a square is 1/5 of a meter. The perimeter of a square is 1/5 of a meter. Okay, so first, what do we know? Let's go back and let's just start talking about what we know here. Perimeter is side plus side plus side plus side, right? And we know that area is length times width. So what are we looking at here? We know perimeter. Okay, so we're looking at side plus side plus side plus side. Okay, the perimeter of a square is 1/5 of a meter. So this plus this plus this plus this is equal to 1/5 of a meter. So what should we do first? Well, find the length of each side in meters, right? So let's start off with the perimeter. So all the way around is equal to 1/5 now of, remember that, a meter. So the perimeter of this rectangle is 1/5 of a meter. So how can we solve this? What do you think? I'm going to give you a chance to play around with this and come back in just a minute once you have written something down. All right, what did you do? So I went back and I tried to make my square look a little bit more square. And because all four sides of a square are equal. So if I take 1/5 and divide it into 4, like because there's 4 sides, here, right here, if this is equal to 1 meter, and this is 1, 2, 3, 4, 5, this one part, 1/5 of a meter, is what we're looking for. So 1/5 divided by 4 sides, there are 4 parts. So 1/5 times 1/4 is 1/20. So the length of one side is 1/120th of a meter. So I'm using the same format that we did before. Now, if we know that one side is 1/20th of a meter, how long is each side in centimeters? Okay, so what do we know about centimeters? So now I want you to attempt this problem by taking your 1/20th and turning it into centimeters. Tell me what you get. So I took my 1/20th of a meter, and remember how to convert. Remember just you going back to what you know. We know that 100 centimeters is equal to 1 meter. So remember, we're converting our 1/20th of a meter into centimeters. So 1/20th times 1 meter. So I'm decomposing this problem right here. 1/20th times 1 meter is equal to 1/20th times 100 centimeters. Then I come down here, multiply and cross cancel, and I get 5 centimeters. Each side is equal to 5 centimeters. All right, let's move on to problem 4. Problem 4, a pallet holding 5 identical crates weighs 1/4 of a ton. How many tons does each crate weigh? Well, what do we know first? Well, a pallet is one of those square shipping. It's like flat and it's made out of wood, and then they stack things on top of it and wrap it with cellophane in order to ship things easily. So that's what a pallet is, number one. And it's shipping, or it has 5 identical crates on top of it. So 5 crates. 3, 4, 5. Okay. And a pallet holding 5 identical crates weighs 1/4 of a ton. Well, how much is in 1 ton? Well, 1 ton is equal to 2,000 pounds, right? Okay, that's what we know. Okay, so question 1. How many tons does each crate weigh? Okay, so I need to break that up. So what do we know? How do we attempt this? I want you to go about this the same way we just started that last problem. Go to what you know. A pallet holding 5 identical crates. How many are you going to break that tape diagram up into? Each crate weighs 1/4 of a ton. How many tons does each crate weigh? So you have to find the weight of one crate and then multiply it by 5, right? All right, let's get started. Come back and check your work. All right, so here's my tape diagram. 5, 1, 2, 3, 4. I have 4. I have a pallet holding 5 identical crates, weighs 1/4 of a ton. So I have 1, 2, 3, 4. 1/4 cut into 5 identical crates, right? So 1/4 divide 5 is 1/4 times 1/5, 1/20th of a ton. Each crate weighs 1/20th of a ton. So how many pounds does each crate weigh? So going back to what we know 1 ton is equal to 2,000 pounds. I want you to take your 1/20th of a ton and I want you to convert it over to pounds. Now, you know how to do it. Start by decomposing your 1/20th of a ton. Replace that with our pounds, right? What do we know about that? That's how you're going to solve this problem. Go ahead and try. All right, so how did you do on decomposing this and converting that into pounds? So 1/20th of a ton is equal to 1/20th times 1 ton. That's decomposing this right here. Then 1/20th times 2,000 pounds, because we're replacing the tons with pounds, right? That's our conversion. That's where it happens. 1/20th time 1 times 2,000 over 20 comes to 100 pounds. Each crate weighs 100 pounds. All right, moving right along. Problem 5 out of 6 problems. All right. Faye has 5 pieces of ribbon. If each is a yard long, she cuts them into 6. How many 6 will she have after cutting all the ribbons? Now go back to what we just did. You have been doing this over and over and over and over. You can do this. And then how long will each of the 6 be in inches? So then we're converting again, right? So from yards to inches. All right, you can do this. Try it out, solve it, come back to check your work. Okay, here we go. Here's my tape diagram. Here is 1 a yard. So 1 divided into 6 becomes 1 times 6. So you have 6, 6. Then if you multiply 5, because we have 5 yards, 5 yards. So 5 times 6 is 36 in 5 yards. So there'll be 36 in 5 yards. All right. Then how long will each of the 6 be in inches? Well, now we're going to decompose 1/6 times 1 yard, 1/6 times 36 inches. 1 times 36 over 6, 6 inches. Each will be 6 inches long, and that's going back to what I already know, right? All right, last problem in our concept development. A glass pitcher is filled with water. 1/8 of the water is poured equally into 2 glasses. So a pitcher is filled with water, and 1/8 of the water is poured equally into 2 glasses. What fraction of the water is in each glass? Then each glass holds 3 ounces of water. How many ounces of water are in the full pitcher? Going backwards and filling up that pitcher. If 1/6 of the remaining water is poured out, how many cups of water are left in the pitchers? Okay, so this is a little bit more advanced, but I really think you can do it. It's just going back and thinking backwards a little bit. And yes, it is going to require a little bit of work. I think I might have to turn the page and do some of my work on the back of this. All right, are you ready? Meet me back here with your attempts to solve this, because I'm telling you, this is going to go exactly with the problem set. So if you're successful with this, you're going to be successful on the problem set, and then the problem set, you're going to be successful on the homework. So let's go ahead and try something, write something down, tell me what you already know, draw a picture. Can you make sense of any of this? And then what can you gather? What information can you gather from your picture? Come on back. All right, so part A, I think it was very accessible to you. So 1/2 of 1/8, or 1/8 divided into 2, coming back up here, is 1/16. So 1/16 of the water is in each glass. I think this problem was probably very accessible as well. Each glass holds 3 ounces of water. How many ounces of water are in the full pitcher? So 3 times 2 is 6 ounces. 1 unit is equal to 6 ounces. And then we have to multiply that by 8 units, going back up here to 8 units. And then so 8 units is equal to 6 times 8 is 48 ounces, or in the full pitcher. Now, problem C is definitely more a complex multi-step problem, and it may have been a little bit hard, but let's go through it really quick together. So here is 42 ounces. Well, how did I get 42 ounces? I did 48 ounces minus the 6 ounces, which remember the 1/4, we're only focusing on the 3/4 now. So 3/4 of 42 ounces because 6 ounces of it got poured out. So 3/4 of 42 is the same as 3/4 times 42. Come down, do the multiplication, is 31.5 fluid ounces. So now I'm converting over to cups. So 31.5 fluid ounces, I decompose the problem, pull it apart, then I put in, this is where my conversion happens. So 1/8 of a cup. 31.5 times 1/8 of a cup, and now I'm going to pull this apart. 31 times 1/8 plus 1/2 times 1/8 becomes 31 over 8 plus 1/16. I need to find a common denominator, and I end up with 62 over 16 plus 1/16 is 63 and 63/16 of a cup, which breaks down to 3 5/16 cups. 3 5/16 cup of water are left in the pitcher after you pour some out, right? All right, that's going to do it for concept development. Now we're going to take a quick look at the problem set. And you're going to notice that these look remarkably similar to what we just went through. Silverstein, Mr. Fan, the perimeter of a square, a pallet. I've just changed the names in the concept development. So how many pounds does each crate weigh? Here's Faye and those ribbons again. And then here is that glass pitcher problem. Here, one more time, just written in a different way. Well, not particularly this one. So can you go through, based on what we just did in the concept development, can you go through and complete the problem set independently and show your work, show those tape diagrams or number lines, however you want to solve, and then come back for problem set debrief to check your work, because after the problem set, of course, you will work on the homework. All right, I'm sure you'll use your notes to help you. All right, good luck.